All right, let's dive right into this explainer. We're unraveling a bit of a mystery today, and it's one that is quite literally hiding right under our noses, or rather, right on our breakfast plates. You probably woke up today, grabbed a quick bite, and didn't think twice about the crazy complex chemistry happening in your food. But the truth is, every single time we cook, we are essentially running a science experiment. And today, we're going to look at one of the most fascinating and honestly most widespread chemical results of that daily experiment. So think about this for a second. What do your morning cup of coffee, that perfect slice of golden brown toast, and a sweet drizzle of honey all have in common? I mean, besides being the best part of the morning. Well, you might not realize it, but these staples all share a hidden, highly scientific ingredient. We consume it almost every single day, completely, totally unaware that it's even there.
Meet 5-hydroxymethylfurfural. Yeah, it's a massive mouthful, so we are just going to call it HMF. It can show up as a crystalline solid, a dark yellow liquid, or even a powder. But the really absolutely crucial detail here is that last bit. It is a major reaction product of non-enzymatic browning in processed foods. Basically, when foods turn brown without the help of enzymes, boom, HMF is born. It's a super common yet totally under-the-radar chemical compound lurking in a ton of our favorite foods.
Now, we're not just guessing or making assumptions here. To really understand what this compound is and whether we actually need to be worried about it, we are going straight to the source. We're basing today's explainer squarely on the official Nestlé food safety brief on the subject. By using this specific data, we can look at the cold, hard facts, dig into the toxicology, and separate culinary fact from fiction.
Okay, here's our roadmap for today. We're going to cover the secret in your breakfast, the chemistry of the crunch, measuring our intake, health risks, and finally, the regulatory response.
Let's kick things off with Section 1, the secret in your breakfast, and how HMF actually gets into our daily diet.
Moving right along to Section 2, the chemistry of the crunch, taking a look at the famous Maillard reaction. So you know that incredible smell of baking bread or roasting coffee? That is the Maillard reaction in action. It's a thermally catalyzed process, and here's exactly how it goes down. Step 1, you've got reducing sugars, things like glucose and fructose, naturally hanging out in your food. Step 2, amino acids and proteins enter the chat. Step 3 is where the magic happens. You crank up the heat. And Step 4, the heat forces those sugars and amino acids to react, creating that gorgeous brown crust and rich flavor, but simultaneously producing HMF as an intermediate product. You literally cannot get that perfect sear or crunch without creating HMF in the process.
All right, Section 3, measuring our daily intake. Just how much of this stuff are we actually eating? Check out these numbers, because the concentration of HMF varies wildly. We're measuring this in parts per million, or ppm. Bread is pretty low, sitting between 3 and 220 ppm. But the second you roast coffee beans, it jumps way up to between 327 and 605 ppm. Instant coffee is even crazier, hitting up to 4,200 ppm. And the absolute highest on the list, caramel products. They can pack a staggering 110 to 9,500 parts per million. Basically, the more intense the heat and the sugar reaction, the more HMF you get.
So what does that actually look like for you and me on an average day? Well, when you tally up all those standard cooked foods, the Nestlé brief gives us a really solid estimate. We are likely consuming anywhere between 30 and 60 milligrams of HMF every single day. That's just our baseline from a normal, cooked diet. But wait, the story actually gets a little deeper. Because HMF isn't just formed by accident in our ovens. It is also deliberately added as a commercial flavoring agent. Look at this list: dairy products, oils, processed fruits, baked goods, meat, fish, and even non-alcoholic beverages. Food manufacturers love using it to boost flavor profiles, and that tacks on about another 1.6 milligrams to our daily intake. Which brings us to a very important Section 4, health risks and toxicology. What does the evidence actually say?
This is where the science gets a little tricky. When we look at the safety data, there is a massive difference depending on how the tests were run. On one hand, you have in vitro, so test tube studies. These did show potential for DNA damage, but only at super high concentrations. They also flagged a metabolite of HMF, known as SMF, as showing potent mutagenic activity. But then you look at the in vivo studies, the live animal tests. When they tested living mice, they found absolutely zero evidence of chromosome damage in their blood cells, even when the doses were so high they impaired the mice's physical growth. It's a really stark contrast between what happens in a test tube versus a living, breathing organism.
And if we look at long-term cancer studies, the results are honestly pretty mixed. In a 2-year study, researchers did find some evidence of carcinogenicity in female mice, specifically an increase in liver adenomas. But in male mice, nothing, no evidence at all. And in both male and female rats, again, absolutely zero evidence. So as you can see, the data is complex. It definitely doesn't point to one simple black and white conclusion.
Given all that conflicting data, let's look at Section 5, the regulatory response. How are the authorities actually handling this?
The short answer? They're handling it with a lot of caution. Believe it or not, there is currently no official safe intake level established for humans. Because the European Food Safety Authority couldn't entirely rule out the risks associated with that HMF metabolite we mentioned earlier, they've actually hit pause and suspended the use of HMF as an added flavor until they get more data. Other agencies are trying to manage it by capping it in specific foods. Honey, for instance, is capped at a strict 40 milligrams per kilogram, or 80 if it's from the tropics, since heat naturally spikes HMF levels. There's even a push to limit it to 25 milligrams in grape must. So regulators are definitely awake at the wheel, actively trying to keep these levels in check.
Which leaves us with this final, kind of wild thought to chew on. Since HMF is a natural byproduct of baking, roasting, and sweetening the foods we absolutely love, where exactly do we draw the line between delicious and dangerous? As scientists keep digging into the true toxicological impact of this chemical, we're left wondering how regulators are ever going to balance the safety of our diet with the fundamental, unavoidable chemistry of cooking. Definitely some food for thought the next time you're waiting for your morning toast to pop. Thanks so much for joining me on this explainer.